So what I'm going to do in this video is actually sort of a speed run of a few problems dealing with the properties of parallelograms. We're just going to kind of go through IXL very quickly and show that these problems are intended to be realistically some of the simpler ones to work with. So we're going to go ahead and jump right into it. We're going to see just kind of how many of these we can get through in a reasonable time. We're given on the left here parallelogram. It says rhombus, but that is a type of parallelogram that has consecutive angles provided. And I know that consecutive angles, so if I add those together, they add up to 180 degrees. So we're going to have to refocus this now that I've written some more stuff down. We'll get over that hurdle there, and we should be good to go. So P plus P is going to be 2P. But I want to subtract that 64 from both sides of my equation. So 180 minus 64, well, that's going to be 116. And that's going to tell me that P should equal half of this, because we're going to divide both sides by 2. And 2 goes into there 58 times. So over here, we're just going to put in that 58, and we should be good to go. Excellent. Now we want to move on. It says find the value of W in this parallelogram. They might sometimes give you extra information. I should point that out. They give us a few different sides to look at and work with here. I think they're hoping to trick us. But I know that this 4W and this W plus 21, the very first thing I told you about properties is they're equal to each other. So let's see, 4W, not plus, 4W is equal to W plus 21. So I'm going to subtract W from both sides to find out that 3W equals 21. That just means W should equal 7 because we're going to divide both sides by 3. So let's go ahead and check that. That's good. All right, properties. Again, we have two things across from each other. We have 3P equals P plus 26. And again, this isn't formal work over here. It's just my scrap work. I subtract P from both sides, and we find out that P should equal 13 when we divide both sides by 2. So right now, these are simpler problems. They're just asking us to solve for the variable. That's not too bad. This one looks good. I like when they give us the diagonals bisecting each other. Pay close attention to what they give you. CF is this little half piece here, and EF is the other half piece. So we said that diagonals bisect each other. That's why I'm calling them half pieces. CF and EF are actually equal to each other still, so this is very much what we've been doing. So I know that V plus 2 would equal 8V minus 40. And you've got a couple ways you could try to set this up here if you'd like. Kind of separate these out. I'm going to subtract this V from both sides personally. You can do it the other way if you want and get 7V on the right. And I'm going to add 42 to both sides. Or sorry, I said 42 because I'm thinking ahead. We're going to add 40 to both sides to get 42 on the left. Well, I know 7 times 6 gives me 42, so V should equal 6. All right, it's terrific. That makes me feel good, right? Parallelogram, we have two consecutive angles. They're adjacent angles. We said that consecutive angles, if you add them together, so let's add these together. If you add consecutive angles together, they sum to 180 degrees because they are supplementary. So 7s and 4s, we'll combine our like terms here. 7s and 4s is 11s. The 74 and the 32 are both negative. So if we think about it like debt, looks like we owe both things. So this is going to be minus 106. Okay. So keeping in mind, all I did was 70 and 30 is 100. 4 and 2 is 6. That's all still equal to 180. And so then I go, well, 11s is going to equal, and I'm going to add this to this side. It's going to equal 286. Now, this one may be a little harder for people to see, so it may be worth kind of doing a little bit of long division over here for just a moment, instead of trying to do this one just verbally. 11 goes into 28 twice. Oh, look at that. That works out really well. So 11 goes into 28 twice. 2 times 11 is 22. When I subtract, I get a 6. So 11 goes into 66 6 times. That means S should equal 26. All right. These two are opposite each other, so they must be congruent. 2p minus 65 would equal p. So I'm going to subtract p from both sides, and I'm going to add 65 to the other side, and just this one's just super fast and simple. I won't even spend any other time talking about it. All right, still rolling through the same kind of thing here. Opposite sides are congruent. Subtract s from both sides, we get 2s. Add 34 to this empty side now, we get 34 over here. And I see that if I divide both sides by 2, we get 17. And there we are. All right, they're still asking us to find the value of p. Let's see if we can get this to move along a little bit. So 3p plus 8 must be equal to 6p minus 13 because we're still dealing with opposite sides here. I'm going to subtract 3p from this side, and I'm going to add 13 to this side, and we're going to get another problem where p equals 7. All right, so again, dh, when these things bisect each other, dh is equal to fh, so very much the same sort of scrap work. 3p minus 30 would equal 7p minus 90. Add 90 to this side, we get 60. Subtract 3p from this side, we get 4p. And when we divide by 4, it looks like p equals 15. All right, we're kind of getting to a point now where we hope they change it up. If they don't, maybe we'll just ride all the way to 100 on the smart score here. We have 2y minus 46 equal to y. We'll subtract y from both sides, we'll add 46 to both sides, and we get 46 here. All right, it looks different, and it is different. This is where you're going to pause. Notice here, they didn't ask us for the variable. We're finally at a spot that I like. This one, we're still going to do our same initial setup. We know that 3t minus 94 does equal t plus 46. That is true. But they did not ask us to find t, so we're going to have to be careful here in a minute. What I'm going to do is go ahead and still solve like I was. I'll subtract t from both sides. I'll add the 94 to this side, so that's going to be 140. And that tells me that t is going to equal 70. Now, it said find the measure of angle S. So I'm going to take 3t minus 94, and I'm going to substitute in that 70 degrees into this problem. And just because we are wanting the sake of time here, we'll just grab a calculator just real fast. And we get 116 for our answer there. So we're just plugging our values back in here. So they're changing it up on us now. They want us to plug it back in. And that's where we notice our first badge pop up because they're saying, look, you've achieved something a little bit more difficult now. So opposite sides are congruent. When I subtract 13 from both sides, we're going to get 40 on the right. And when I subtract s, I'll get 8s on the left. And then from there, we divide both sides by 8, and we get 5. And it wants us to find the length of EF. Well, EF is this side over here, which is the same as the length of CD. So 5 times s, so 5 times my 5 I just found here, would be 25. Oh no, I typed a wrong number in. So we knew what that was, but I accidentally hit an extra number. All right, that's fine. Consecutive angles. Consecutive angles add up to 180 degrees. We have 8b minus 68 equals 180, so I just combine my like terms. I'm going to add 68 to both sides. We get 248. So b would have to equal 31. So we divide both sides by 8. But it wants the measure of angle J. J is the opposite of 2b plus 4. So 2 times 31 plus 4 would be 62 plus 4 be 66. All right. So I would push this to 100, but we're starting to see they're very repetitive problems. They don't change very much. What I'm going to do is just jump some levels and see if anything else interesting happens. It looks like these are all pretty similar from here. So if there are any questions about this type of thing, of course, you can always comment, message. But yeah, these all look pretty good. The only difference on these higher level ones is that they're asking for 2 pieces of information instead of 1.